Hi everybody, this is Kent, and in this episode we're building this post and beam greenhouse in the garden. This post and beam greenhouse worked out way better than we expected. Here's some animation to show you how we put it all together. The greenhouse has a poured concrete foundation with embedded anchor bolts and galvanized post saddles. In each corner stands a 6x6 post. The beams running north to south are made from two sections bolted together and sit on top of the posts. There's 2x4 stud walls on the east and west side. Then, 4 curved corner braces are flush mounted with lag bolts. 2 6x6 cross ties fall into the dados cut in the north-south beams. Another stud wall runs across the rear, north-facing side of the greenhouse. The doorway in the front is framed out with 2 4x4s, and stud walls on each side of the doorway finish the front. Galvanized drip edge flashing is then nailed to the bottom of each stud wall. A 2x6 rafter tie adds strength across the long beams. Temporary braces are added to the cross ties to support the ridge beam, and this beam also is made in 2 sections. Now all the rafters are cut and can be set and screwed to the north-south and ridge beams. After that, the temporary ridge beam supports are removed. 2x4, then 2x6 blocking is added mid-span between the rafters and also on top of the beams. Then fascia boards are screwed to the rafter tails. Twin-wall polycarbonate glazing is cut and screwed to the east and west-facing walls. A door, threshold, and frame is installed between the 4x4s, and more glazing completes the front and rear walls. Roof glazing sheets are cut and attached to the rafters and blocking. The gable ends have a few 2x4s to complete the frame and support the last of the greenhouse glazing. And that framing will support the louvered gable vent and a rear exhaust fan. 2 additional louvered vents are added low on each wall for more airflow. The ridge cap is made in several pieces. First, there's a custom wooden cap, followed by a galvanized preformed top cap. We will start with building concrete forms and pouring the foundation. And that all began 3 years ago with some spray-painted lines on the grass in a corner of our garden and my neighbor's excavator. And we needed to remove the top post of the vehicle gate to fit the excavator in. In this video, I'm going to cover all the major steps we took in the construction of this greenhouse. Then I'll be putting out a 4-part series that covers everything in greater detail. So look for that playlist coming right up. This is by no means a production greenhouse. I wanted to stay with a post and beam or timber frame look to match other structures I've built on our property. There's a slight downslope to the north that leads to the road, so my neighbor Charlie would scrape off the grass and topsoil to make a level rectangle for the foundation. So after I got the size and design worked out, we found a sunny place in our fenced garden for it to go. And it's directly across a pathway to the potting bench I built 2 years ago. After that, I dug some trenches for a perforated drain pipe, and this would collect water from under and around the greenhouse and move it out to the ditch by the road. This pipe and trench is lined with landscape fabric and filled with drain rock, and I was able to tie into an existing line just outside the fence. When I was done installing and burying the pipe, I added a few yards of crushed stone before starting the concrete forms. The foundation is a rectangle that's 10 feet wide by 12 feet long. I stacked 2 1x8s for the form walls, so the height of the foundation is around 14 inches. The stacked 1x8s are held together with vertical 2x4s, then 2 more 2x4s running horizontally, and this has worked out well on other pours we've done. We live on the west coast, and our winters are generally pretty mild, so I can get away with pouring this foundation at a shallow depth. Other buildings and workshops on our property were built this way, with no sign of heaving, so I decided to follow that. So I can position, level, and square the inner and outer walls of the forms, and then stake and brace them in place. I bent some rebar and suspended it from wire, and added some 1x2s across the top of the forms to hold the anchor bolts in place. The form work is labor intensive, but the materials and concrete is not particularly expensive for this pour. I want my projects to last, so I'm happy to put in the extra effort if that's what will make the difference. Rebar too is not very expensive, so I put 2 rows of it in. The wood for the form walls I was lucky enough to buy a few years ago, so that wasn't too bad either. And I will use all those 2x4s and 1x8s again in some other project. I have a small concrete mixer that can handle 2 bags at a time, so it was a full day for Marilyn and myself to do this foundation pour. I did the mixing and finishing, and she filled the forms and settled the concrete. Galvanized 6x6 post saddles were set into the wet concrete at each corner, and 4x4 saddles on each side of the doorway. A few days later, I stripped the forms and everything looked good. Nothing moved or bowed out during the pour. With all my timbers and boards selected and brought into the garden, I can start cutting and notching and finishing each of the pieces for this build. This is not timber framing, and the joinery I'll be using is fairly simple and straightforward. I'll start with the 4 6x6 corner posts. I cut them to length and trim down the bottom ends so they'll fit in the saddles. You can get saddles that will accommodate a full dimension 6x6, but they're special order in my area, so I use the ones designed for a nominal 6x6, that being one that's 5.5 inches square. It's no big deal to shave these down with a series of wafer cuts. I then break those off with a hammer and clean up the rough edges with a chisel. The posts and cross ties will be made from grand fir. This type of fir is not very weather resistant, so I'll add a few extra coats of stain to them. I was short on cedar 6x6s, so I needed to substitute. For all the posts, beams, ties, and rafters, I chamfered the edges with a power plane and a sanding disc on my angle grinder. Then I rolled 3 coats of stain on these fir posts and let them dry overnight. I can now stand each post up and secure them with screws through the saddles and into temporary braces staked to the ground. Now I'll make the north-south beams, and these would be 16 feet long. I didn't have any 6x6s that long, so I'd have to make them from 2 pieces, and I decided to make a simple scarf joint in the end of each and bolt them together into one. As there's a stud wall under these beams, the scarf joint would not be under much load, if any, but I built them as if there would be, and then I could count on them holding up well when I set them across the posts. After squaring this end of the 6x6, I made a shoulder cut and then a rip cut on opposite sides with my circular saw. Then I finished the cuts with a handsaw. I countersunk and drilled holes for the bolts in one end of the scarf cut, then clamped on the other scarf end and drilled through it. Don't get too judgmental here, but I did add some construction adhesive in this joint before I clamped it back together and tightened the bolts. And I liked how it sealed the slightly rough edges of my not-so-perfect joinery. Did I say I wasn't a timber framer? Oh, well, I'm not. But I think these joints worked out pretty well. And now I have 2 6x6s long enough to make the next cuts. And that will be squaring up an end and marking and cutting the quarter ellipse profile. I have a long blade for my jigsaw for this. I can't push it too hard though. It's western red cedar, but I'm basically ripping with the grain, and it's a 6-inch deep cut. These beams sit down on the post an inch, so I can now cut that shallow dado with my circular saw. I'll rotate that beam 90 degrees toward me, then cut another deeper dado that will accept the end of the cross tie. At this joint, there's 2 holes required for the lag bolts that will hold the beam to the post and the beam to the cross tie. The cross ties are cut to length and a lap cut in each end. That's so the cross tie will also sit down on the post an inch. And the front cross tie also needs 2 dados in its underside to accept the 4x4s that form the doorway. The north-south beams are stained and ready to be lifted into place, but I decided to install the east and west stud walls first. That way we can drop the drilled bottom sill plate over the anchor bolts, and Marilyn came to help me carry and drop these in. And with those two walls in place, my neighbor Calvin came over to help me set the beams on the posts. I have a full set of plans available for download from my website, manaboutTools.com/greenhouse, and I'll have a cut list and links to a hardware list as well. I'll drill a pilot hole through the beam and into the top of the post, then run in a lag bolt. And then we set the rear stud wall in place. Then the rear cross tie can be dropped in over the wall. Then followed by the front cross tie. And I'll drill horizontally now through the beam and into the end of the cross tie, and run in a lag bolt. The 4 curved corner braces are held in place and pilot holes drilled into the post and into the beam. And lag screws secure them, and the angle of the pilot holes tighten it toward the corner. These braces are flush mounted, and I've used this design on a few other structures. The 4x4 door frame posts are then set in place and plumbed, and screwed to the front cross tie and the post saddles. And the last 2 wall sections are set in over the anchor bolts. The pilot holes for the bolts were angled so I could set them in, then rotate the top of the wall up under the cross tie. Like the north-south beams, the ridge beam is also made in 2 pieces. I cut a lap in the end of each of the 2x8s, then glued and screwed them together. I used some angle brackets and mending plates here. Here's the first temporary brace I made to hold the ridge beam in place. These were carefully lined up at the center of the cross ties, and an additional angled support running to a 2x6 rafter tie that connects the north-south beams mid-span. The ridge beam is cut to length, stained, then lifted and slid into these temporary supports. With that ridge beam secured to the temporary braces, I now can start to work on the rafters. And I went back and checked some dimensions of the structure and compared it to my SketchUp model. And that helped me fabricate a template so I could copy this onto the 2x6 blanks I had selected for the rafters. And that looked like it fit well enough, so I started to copy the ellipse profile and the peak angle on the cedar 2x6s. And I can cut the rafter to length on my miter saw, then cut the tail profile with a jigsaw. And I can chamfer the edges while holding it in this improvised slot jig. Then I stained each rafter and let them dry. Then I reconsidered the bird's mouth depth of my first pattern. I thought it might be a bit too deep, so I cut a new rafter pattern with a shallower notch and checked its fit. I liked it better, so I went ahead and copied this cut on the rafters. And it fit well, so I attached all the rafters to the beams that afternoon. I made pencil marks along the beams for the location of each rafter. And this is the last one going up on the north-facing gable end. The next day, I cut and installed the 2x4 blocking between the rafters at the midway point between the ridge beam and north-south beam. Then I added some 2x6 blocking at the top of the north-south beams. And these ones had an angle ripped to match the slope of the roof. And I added some flat-mounted corner braces to the inside of the stud walls. These are the same shape as the outside braces, but they were cut from 1-inch thick stock. Next, I added some 1x4s for the fascia boards, and they're attached to the rafter tails with trim screws. I removed the temporary braces supporting the ridge beam, as they're not needed anymore. And I'll add some framing at each gable end. These 2x4s will support the glazing, and the square opening will be used for a vent at the front and a fan at the rear. The door is made from 2x4 and 2x6 cedar. I cut lap joints at the corners that are glued and screwed together, and the mid-rail has a lap that fits into 2 dados. And I'll cut a relief with my router for the polycarbonate glazing, and that will be added after the door is hung. Each polycarbonate panel is cut to size with a fine-tooth blade on my circular saw. I use an aluminum straight-edge clamp to the glazing and to my improvised work table. I screwed some 2x4s to sawhorses to make a surface big enough for the 4-foot by 8-foot panels. And I marked and drilled pilot holes with an oversized bit for the roofing screws I'll be using to attach the panels. You need to make allowances for expansion and contraction of the polycarbonate. After cutting and drilling, I blew out any chips within the wall with an air compressor. The bottom and top of the glazing panels are sealed with plastic J-channel. The bottom channel has holes spaced every 12 inches or so to allow for condensation to drain. And these wall panels are held in place and roofing screws run into the studs. I left a small expansion gap between the panels that I'll be covering with cedar strips. And that's the first wall done. I repeated that all for the identical west wall. I clamped some stops to the fascia to hold the roof panels in place, and I also added some thin spacing strips attached to rafters for the expansion gap. I'll add the bottom J-channel to the roofing panels later, once the entire side is complete. Between the panels on the roof, I will slide in an H-channel to seal this edge. And here's the east-facing roof done. That lower J-channel bridges across panels, and it has some clear silicone added to keep snow from pulling it off in the winter. And the next day, I added my stops to the west side fascia, cut, drilled, and then slid the panels up into place, then ran in screws through the pilot holes like before, and slid in and attached the H-channel. And the H-channel is also screwed to a rafter. The galvanized ridge cap I selected will be lifted higher by a wood cap I made from ripping down some concrete form lumber. This will keep the metal cap separate from the polycarbonate to ward off any heat damage in the summer sun. This wood cap also has a strip of 3/8 plywood to mimic the shape of the metal cap. To install these cap sections, I made a ladder to lay over the polycarbonate panels, so I could crawl up there without causing any damage. I made a sturdy rail attached to the rafter tails to hold the bottom of the ladder. So now I can screw on the wood cap sections, then add the metal cap over top. And this looked pretty good, I thought. I have glazing panels to add to each side of the doorway. And I used the same cedar strips at the edges of the panels as I did to bridge the gaps on the sidewalls. I then cut some triangle-shaped polycarbonate to fill in the gable ends. And to finish the glazing, I'll add panels and cedar strips to the back wall. A thermostat-controlled louvered fan is installed in the opening in the north-facing gable. I made 3 wooden louvers from red cedar. I glued and tacked them together with an air nailer and a few trim screws here and there. Then a light sanding and finished them with several coats of stain. I installed the door with 3 gate hinges screwed to the 4x4 posts. I tacked on some spacers to the cross tie and the posts to center the door, and to hold it flush to the inside face of the post while I ran in screws. Later, I'd come back and add a simple gate handle, plus a spring-loaded screen door latch. I made a door threshold from 2x6 treated lumber and attached it with screws into plastic anchors that I drilled and tapped into the concrete foundation. A bead of clear silicone is added to the routed inside edge of the door, and the rectangle glazing pieces are secured with washer head screws. The louver vent in the gable is installed in the opening and held with screws. And here's the sidewall vents going in. And then some hardware cloth was stapled on. Later, I'll come up with a way to control the airflow through these vents when the temperature in the greenhouse increases. And that's about it. The greenhouse is done. Please leave me a comment or any questions you have. See the links in the description and at the end of this video for the detailed build series. Thanks for watching, and we'll see you next time.